Hello, and welcome to Aggressive Physics. Today is day 86, and what I'd like to discuss today is beats. Now, yesterday we discussed resonance, which is when objects vibrate at a frequency called their natural frequency. Tuning forks have a specific frequency at which they vibrate, and you always produce the same note with a tuning fork. If you were to deform or damage the tuning fork, that natural frequency may change. Now, beats are when you have two waveforms that are very close in the same pitch, but not exact. And what happens is they'll interfere with each other in a way that produces what we call a beat pattern. Now, a beat pattern is an alternating loud and soft warble is what we call it. And you'll see that if we have two frequencies that are very close together, for example, if you have 256 and 260 hertz, what will be produced is a beat pattern of 4 beats per second. So you'll hear an alternating loud and soft warble 4 times every second. So the frequency would occur 4 times a second. Now the beat pattern that's produced would look like a loud and soft and then a loud and soft pattern alternating kind of like a what we call a warble, but what would be loud then soft, like wow, 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 like that. Now, I know I'm not an actual wave pattern, that's a simulation. So don't be alarmed. There was no actual emergency during that sound pattern. As far as the beats go, we do have a way that we can calculate how many beats per second. If you caught on before, I mentioned 256 and 260. Well, we produce 4 beats per second. It's not a very high-tech mathematical equation that we use. We just subtract the two. Now, the human ear can only detect about 8 beats per second, possibly 10 beats per second. And of course, just like everything else, some people can detect more than others. And what we can do is use the beats to actually tune an instrument. If you tune an instrument by using one string, for example, on a guitar, to tune one string to the next, what you're doing is listening for beats. When guitar strings are in tune, you're not going to hear a warble at all. But if they're close and they're just slightly out of tune, you'll hear a number of beats per second. And like I said, it's an alternating loud and soft, like a wow, wow, wow type sound. Once again, there was no actual emergency. I know it sounded like the emergency broadcast system, but I am perfectly safe during this video. Now, with that said, we can also figure out the frequency of the sound that's produced when those two waves collide. Now, you'll hear a warble, but those two waves will collide and form a new wave that will have a different frequency than the originals. And basically, all you have to do is find the average between the two. So the 256 and 260, the resulting waveform would be 258 hertz. So when you try to tune an instrument by using beats, you're listening for the notes produced being the same as opposed to being slightly off. When we do calculations with it, we have two different things we do. Either we subtract the two to find the number of beats per second. Anything higher than about 8 or 10, you're not going to notice it. If that were the case, when choral groups or bands are trying to play two different notes at the same time, we would constantly hear a warble even when we're trying to play chords or trying to make harmonies. So the fact that harmonies and chords and different notes can be played simultaneously without being annoying or hurtful to the ears, that is because our ears can't detect more than 8 or 10 hertz. Now, depending upon the musical taste, certain people may find certain types of music to be hurtful to their ears, but it has nothing to do with beat patterns themselves. Now, with that said, that concludes our discussion of beats. Beats are when two waves that are close together in pitch overlap, and they produce what we call a warble, an alternating series of loud and soft noises, like a wah, 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 wah. If we were to have two notes that were the same, they would combine constructively, and you just hear one note a little louder than each individual note by themselves. So if you tune an instrument using beats, you're trying to produce a louder sound without any warble. All right, beats occur when waves are very close to the same frequency, but not exact. So what you're going to hear is if you have a 256 hertz and let's say 260 hertz, when those frequencies collide, they're going to be slightly off. And it's hard to draw that, but what will end up happening is you'll have a situation where the combining wave has a loud and a soft, and then a loud and a soft, and this occurs, in this case, 4 times every second. So in order to figure out the number of beats you would hear, you would subtract the 2. So 260 and 256, you would hear 4 beats per second. So the times in this case, it's 4 beats, BPS, beats per second. Now the resulting frequency of that sound is the combination of the two, the average. So 256 hertz plus 260 hertz over 2, and that would be 258 hertz. The sound that's produced is a warble, and that alternating loud and soft note is that 4 beats per second. You'd hear 4 beats per second. As we get this closer and closer, you would hear less. You know, if it was 257, it would be 3, 258, 2, 259, 1. And then ultimately, when they're the same note, they would collide constructively, and you would end up getting a single note. People use beat patterns to tune guitars just like they would use resonance, but in this case, you're listening for that warble. And when you don't hear a warble, when you hear a single note, you don't hear that wah, 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 that beats pattern, you would be in tune. So you can use beats to tune an instrument just like you can use resonance.